So this is level 14, lecture number 1. Okay, so for this lecture, we'll be discussing about distance, displacement, speed, velocity, and acceleration. Okay, so lahat ng i-discuss natin dito, ang tawag doon is kinematics. So kinematics is a branch of physics that focuses on the study of moving bodies. So lahat ng mga terms na aaralin natin ngayon, lahat to meron tong kinalaman sa kinematics. Now, sa kinematics, meron tayong dalawang types of quantities na may encounter. Ito yung scalar and vector quantities. Ang scalar quantities, these are quantities which are fully described by a magnitude alone. So, for example, mass, temperature, and speed. So, mga scalar quantities natin, meron lang siyang number at unit. So, for example, 25 kilograms o kaya 36 degrees Celsius or 24 kilometers per hour. So, meron tayong number tapos yung unit. Now, when we say vector quantities, these are quantities which are fully described by both a magnitude and a direction. So, for example, meron tayong force, velocity, and displacement. So, para rin siyang vector quantities, kaya lang ang difference, meron tayong kinoconsider na direction. So, for example, meron kang wind speed na 25 kilometers per hour southwest. Or another example is, let's say, 4 meters north. Now, let's consider the distance. So, distance is a scalar quantity which refers to the length of a path an object covers without considering its direction. So, ang distance is an example of a scalar quantity. So, ibig sabihin, wala tayong kailangan i-consider na direction. Okay, so for example, naglalakad ka ng paikot sa isang basketball court. So, yung distance is yung haba ng nilakad mo. So, kung piikot ka sa basketball court, maglalakad ka ng paikot, ibig sabihin, yung equal yung pinaka-total distance na na-cover mo ay equal dun sa perimeter na ang court. So, paano ba tayo mag-solve ng perimeter? Di ba sa math, kung perimeter yan ng rectangle, that means you just have to add all the sides. So, ibig sabihin, 2 times the length plus 2 times the width. Now, yung displacement naman, this is a vector quantity which refers to the measured length between the initial and final positions of an object with respect to a reference point while considering the direction to where it moves. Okay, so take note of this term. So, we are considering a reference point. Okay, so pag sinabi niyong reference point, ibig sabihin, very important dito kung saan ka nagsimula. Okay, so for example, kung meron kang alam na shortcut papunta sa isang lugar, yung haba ng shortcut o yung distance ng shortcut, yun yung tinatawag natin na displacement. Kasi for example, sa isang lugar, maraming ways para makarating doon. So, kung pupunta ka from one place to another, yung total na haba ng nilakad mo or na tinravel mo, yun ang distance. Pero pag sinabi natin displacement, let's say, from the same point, okay, pupunta ka dun sa same destination, pero may alam kang shortcut. Yung shortcut na dinaanan mo, ang tawag doon ay displacement. Usually, minsan ang displacement ay tinatawag din na this is the shortest distance. Okay, shortest distance from your starting point to your end point. So, para mas madali nating matandaan yung pagkakaiba ng distance and displacement, so let's have an example. Okay, so for example, a man walks 4 meters east, 2 meters south, 4 meters west, and 2 meters north. So, para ma-compute natin yung total distance, ang kailangan lang natin gawin, i-add lang lahat ng distance. So, sa example na to actually, meron tayong 4 distances, diba? So, meron tayong 4 meters east, 2 meters south, 4 meters west, and 2 meters north. Pero since na-describe natin na yung distance is only a scalar quantity, ibig sabihin, hindi natin kailangang isipin yung directions. So, ang gagawin lang natin, i-add lang natin yung 4. So, pag in-add natin lahat yan, 4 meters plus 2 meters plus 4 meters plus 2 meters. The answer is 12 meters. So this is the total distance. Now, tingnan naman natin to. So, kung i-compute naman natin lahat ng displacement sa y-axis. So, add natin. Ano ba yung nasa y-axis? Yun yung nasa direction na south and north na given din sa problem. So, i-add lang natin sila. So, yung south, ang sign niya dapat ay negative. Yung north, ang sign niya dapat ay positive. So, pag in-add natin to, negative 2 plus positive 2 meters, the answer is 0. So, para ma-compute yung total displacement, gagamit tayo ng Pythagorean theorem para mapagsama natin ang x and y axis. Kasi kanina nag-compute tayo, sineseparate natin yung along x dun sa along y. Okay, so para gamitin yung Pythagorean theorem, so we use this formula. So, yung total displacement, okay, is equal to the square root of the total displacement along x squared plus the total displacement along y squared. So, obviously, since 0, parehas yung sagot. So, lalabas ito na ang total displacement natin ay 0. Okay. Now, ano ibig sabihin kapag 0 yung displacement? Ibig sabihin ba hindi gumalaw yung body? Hindi ganun. Kasi, kung nakita naman natin kanina, yung displacement niya ay may mga displacement siya eh. Okay, kaya lang, pag tinotal mo siya, baka siya naging equal to 0. Kasi ang ibig sabihin lang nito, bumalik yung object natin doon sa point kung saan siya nagsimula. Okay, so yun ang ibig sabihin nun. So, ang starting point at ang end point ay parehas lang. As if umalis ang object and then bumalik lang kung saan siya nagsimula. So, ang ibig sabihin, ang total displacement natin ay hindi kaparehas ng total distance. Kasi kung napansin nyo kanina, yung total distance natin is 12 meters. Ito yung example ng parang kang naglalakad sa isang basketball court. Let's say, nagjo-jogging ka paikot sa basketball court. So, kung nagsimula ka sa isang corner at babalik ka din dun sa same corner na yon na lumakad ka o nag-jogging ka ng paikot, yung total distance mo, that is, for example, dito, 12 meters. Pero ang displacement mo, 0. Kasi bumalik ka rin kung saan ka nagsimula. Yan. So, sa pag-compute ng total displacement, gumagamit tayo ng trigonometric laws and formulas. So, para ma-recall natin, ano-ano ba yung mga trigonomic laws and formulas na pwede natin gamitin sa pag-compute. So, ito yung mga examples. So, meron tayong Pythagorean theorem. So, that's this t squared equals dx squared plus dy squared. Pag sine law, this is an example. So, yung a over sine a equals b over sine b equals c over sine c. Or pwede rin cosine law. Yung c squared equals a squared plus b squared minus 2ab cosine c. Okay. So, pag nagko-compute tayo, meron tayong tinatawag na component method for calculating vector quantities. Sa physics kasi, ito yung pinakamadaling paraan ng pagko-compute kapag yung mga i-add mo na vectors ay acting on different angles. Okay? Kasi madali lang mag-add kung same axis sila. For example, lahat sila nasa x-axis or lahat sila naka y-axis. Madali lang yon. Pero paano kapag mayroong iba nasa x, mayroong iba nasa y, mayroong iba may certain angle. So, para mas madaling mag-compute, ginagamitan natin siya ng component method. So, paano ba itong component method? Yung component method ay ginagamitan ng mga inaral natin sa Pythagorean theorem. Okay, so let's have an example. Okay, so let's say meron kang x and y axis dito. Okay, at along that meron kang vector. Okay, so let's call this as your vector A. Okay, na itong vector A na to, meron siya tinatawag na components. Okay, so yung component niya is yung horizontal component, tawagin natin siyang AX. And then yung isa, yung vertical component, tawagin natin siyang A sub y. Okay. So yung vector A has an angle of theta with the x-axis. Ayan. For example, ito x-axis natin, nag-measure tayo ng angle in a counterclockwise direction, which is given by the angle theta. Okay, so now let's compute A and X using sine and cosine ratio. Okay, so i-drawing muna natin ang AX. So, paano natin i-drawing ang AX? So, ang dulo nito ay kapantay ng A. Ito yung dulo ng A. Pero nakalagay siya sa dito. Nakalagay siya sa x-axis. Pero katapat siya nitong dulo ng vector A. Okay, so, ganito magiging itsura niya. Yan. So, ito yung A sub X or the horizontal component of A. Okay, next, yung A sub Y. Okay, so ang A sub y ay nakalagay sa y-axis. Okay, so dito yon y-axis, na ang dulo niya ay katapat din ng A. Okay, katapat siya ng A. So, ito siya. Yan. Ito yung A sub y, or ito yung tinatawag natin na vertical component of A along the y-axis. Okay. So, mapapansin niyo, makakabuo tayo ng right triangle. Okay? Right triangle mula sa drawing. Ito yung 90-degree angle mo. Okay, so i-derive natin ang equation na gagamitin natin sa trigonometric ratios. Okay, so ito yung right triangle na dinrawing natin kanina. Okay, so para ma-define natin ang cosine x, so ang cosine x is ito. So, cosine x, that means it is the adjacent over the hypotenuse. Okay, kaya AX over A. Next, let's transpose. So, papansin nyo, kung ita-translate natin tong equation na ito, ita-transform natin, para ma-solve natin ang AX, kailangan mo lang i-multiply yung A at saka yung cosine X. So, parang ganyan. Parang cross-multiply mo lang siya. So, therefore, para makuha natin ang horizontal axis ng A, that is equal to A, vector A times cosine theta. Now, tinaman natin yung sine theta. So, yung sine theta, remember that sine is opposite over hypotenuse. Kaya ito, naging A sub y over A. So, kung isosolve natin yung A sub y, ibig sabihin kailangan lang natin i-multiply itong dalawa. Okay, kaya meron tayong A sub y equals A sine theta. And then finally, tingnan natin yung tangent theta. So, tangent theta is equal to, okay, opposite over the hypotenuse. Yan, kaya A sub y over A sub x. Now, kailan natin ito pwedeng magamit? Pwede natin itong magamit kapag, let's say, hanapin natin yung value ng angle. So, gagawin lang natin, i-inverse lang natin siya. So, inverse tangent of A sub y over AX. Now, since right triangle siya, pwede rin natin gamitin ang Pythagorean theorem. Yan. So, pag Pythagorean theorem, ito na siya. Yung A, yan, kasi siya yung hypotenuse dito, kaya A squared. And then, yung dalawang sides, yan yung AX at saka AY. Kaya naging A squared equals AX squared plus AY squared. Okay, so, ito yung mga formulas na gagamitin natin kapag magsosolve tayo using the component method. So, para mas madaling yung matandaan, imagine this. Kapag nagsosolve ka ng x component, ang ginagamit mo parati ay cosine. kapag nagsosolve ka ng y component, ang ginagamit natin parati ay sine. Kapag nagsosolve ka naman ng angle, parati tayong gumagamit ng inverse tangent. Okay, let's have example number 1. So, find the components of z. So, vector z is 55 meters. The angle is 30 degrees north of. Okay. So, kung ito yung drawing natin, okay, so ang una natin gagawin, of course, consider muna natin yung mga given. Okay. So, gagamitin natin yung, ito yung given natin. So, 55 meters. And then, hanapin muna natin yung angle theta. So, paano natin malalaman ang angle theta? Siyempre, drawing muna natin siya. So, pag drawing mo tong 30 degrees north of east, ito yung direction ng north, ito yung east, nasa yung 30 degrees north of east. So, ito yun. Ayan. Ibig sabihin ito, pag mayroong ganitong mga directions, always remember, dito ka magsisimula sa dulo. So, dun sa second direction, dun ka mag-start ng mag-measure pataas or papunta doon sa next, sa unang direction. Kaya ito, kung ito yung east, aakit ka papuntang north, ganun ang pag-measure ng 30 degrees. Okay. So, dito, kapag, kailangan nyo tandaan na kapag gagamit kayo ng angle theta, hindi ibig sabihin na yung angle theta ay yung angle na given nyo rito sa problem. Hindi ganon. Kasi kailangan ng angle theta parating magsisimula doon sa positive x-axis. So, ito yun. Dito ka parating magsisimula. Now, nagkataon lang na dito sa given natin, yung 30 degrees ay yun na rin yung angle doon sa na nagsisimula doon sa positive x-axis. Kaya, ito na rin yung angle na gagamitin natin sa pagsusolve. Okay. So, for example, you have here zx is equal to z cosine theta. Diba sabi ko kanina, pag isosolve nyo ang x component, gamitan nyo lang siya ng cosine. So, pag sinubstitute natin siya, meron tayong 55 meters times cosine 30 degrees equals 47.6 meters. Ang zy, okay, remember, kapag nagsusolve ka ng y component, ang kapartner niya ay sine. Okay? So, pag sinolve natin siya, this will be 55 meters times sine 30 degrees. So, that's equal to 27.5 meters. Okay, so, yun na yung sagot natin kanina. So, yun na yung pag-solve ng x and y components. Okay, now let's have another example. So, this time, mayroon tayong example. So, example number 2, find the components of vector b, 50 meters, 25 degrees west of south. So, parati natin unang gagawin, ito-drawing muna natin siya. Okay. So, dito, sabi 25 degrees west of south. So, ano ulit sabi ko kanina? Kailangan magsisimula muna tayo ng direction sa pagsusukat mula dun sa second direction. Sa huling direction na binanggit. So, meron tayong south. So, dito ang south, pupunta ka sa west. Okay? So, ito yung papuntang west. So, therefore, yung 25 degrees measured from south going to west. Kaya ito yung 25 degrees natin. Now, ang tanong, ito na ba yung angle na gagamitin natin? Hindi pa. Okay? Kasi remember, ang angle theta ay yung angle na sinimulan i-measure from the x-axis, positive x, going in a counterclockwise direction. So, ibig sabihin, ito yung angle na theta dapat. Yan, yun yung measure na yon. Okay, ano yung angle na yon? So, remember, mula dito hanggang dito, okay, that is equal to 180 degrees. I-add natin siya dito sa angle na to. Or better yet, ang pinakamadaling paraan is, remember this, mula dito, pa counterclockwise hanggang dito, this is already 270. Okay? So, gagawin lang natin, 270 degrees minus, ito, 25 degrees. Ayan, ito yung angle na yan. So, this is 245 degrees. So, ito yung 245 degrees, yung gagamitin nating angle sa pag-solve ng x and y components of vector b. Okay, so now, solve natin yung x component. So, x component natin will be b times cosine theta. So, this is 50 meters times cosine 245 degrees. So that is equal to negative 21.1 meters. And then b sub y, so b sine theta, kasi magsusolve tayo ng y. Kaya 50 times sine 245 is negative 45.3 meters. So, kung papansin niyo, bakit negative? Okay. Remember kanina, diba, kapag nagsusolve tayo involving vector quantities, kapag ang direction ay west at saka south, siya ay negative. Ito kasing bx, ito yun yun. Ito yung bx. Ayan. So, nasa west direction siya, kaya siya negative. Yung b sub y, okay, nandito siya. Okay, nasa south direction. Kaya siya ay negative 45.3 meters. Okay, so now let's have an example. So this time, it's a word problem. So a ship travels 55 nautical miles on a bearing of 27 degrees and then travels a bearing of 170 degrees for 140 nautical miles. Find the distance and displacement of. Okay, so parating una natin ginagawa dito, kukunin muna natin lahat ng given. Okay, so ang given natin, okay, yung first displacement natin, that's 55 nautical miles. That's 27 degrees true north. And then D2, okay, D2, this is 140 nautical miles, 117 degrees true north yung bearing niya. Okay, so pinapahanap sa atin is find the total distance and find the total displacement of the ship. Okay, kung magko-compute tayo ng distance, so sobrang dali. Kasi wala na tayo pakialam na sa direction. So, kailangan natin lang gawin, i-add lang natin tong dalawang distances. Kaya, dt is equal to d1 plus d2. So, dt is equal to 55 nautical miles plus 140 nautical miles. So, we have 195 nautical miles. So, madali lang pag kumukuha ng distance, i-add lang natin. Okay, so therefore the total distance is 195 nautical miles. So next, let's solve for the displacement. Okay, so para makuha ang total displacement, kailangan muna i-drawing natin ng vectors. Okay, bakit important ito? Kasi di pa kanina nabanggit ko na ang angle na gagamitin natin sa pagko-compute ay yung angle na sinukat mula din sa positive x-axis going in a counterclockwise direction. Okay? Pero dito sa given natin, bearing kasi ang binigay. Kaya sa north tayo magsisimula ng sukat in a clockwise direction. So, i-plot muna natin siya. So, pag pinlot natin, ito yung D1, ito yung 27 degrees true north, starting from the north. So, this is your D1, which is 55 nautical miles. And then yung dito mo, na 140 nautical miles, this is 117 degrees starting from the north. Okay, going down here. So, ito yung 117. Okay, so papansin niyo meron tayong dalawang angles. Okay, so ang tinatanong is the displacement. Okay, so ang displacement natin, okay, para ma-solve natin yan, gagamitan natin siya ng vector analysis o yung component method. Okay, next naman, kukuhanin natin na angles na gagamitin sa pagsusolve. Since alam na natin kanina yung mga angles niya kapag pinlat natin siya, so sukatin natin ngayon ng angle from the x-axis in a counterclockwise direction. So, dito tayo magsimula. So, sa D1, magsisimula tayo dito. Positive x going here sa D1. So, this is equivalent to 63 degrees. Okay, paano nakuha yung 63 degrees? Yung ano lang, simple lang. Ito kasing isang buong to, di ba this is 90 degrees. So, ibig sabihin, 90 minus this angle na 27, you get 63 degrees. Now, yung isa naman, yung D2, okay. So, dito naman, okay, starting from positive x, going in a counterclockwise direction. Okay, ito yon. Ano yung angle nito? So, remember na kapag gumawa ka ng isang buong ikot, okay, so pag gumawa ka ng isang buong ikot dito, ayan, so pag umikot ka dyan, that is actually equivalent to 360 degrees. So, 360 degrees minus this small angle here. Okay? So, paano malalaman ko ano yung angle na yun? Diba kanina ang given dito is, ayan, bearing 117. Ito yun eh. Ito yung 117. Pero ito ay 90. Okay? So, sabihin yung 90, ima-minus mo siya sa 117 para makuha mo yung angle dito. Okay? Kaya naging sagot dito ay 333 degrees. Okay, next. Ang gagawin natin, kukunin natin ang x and y components ng dalawang given displacements. Yan na. So, solve muna tayo sa D1. So, kunin muna natin yung x and y components niya. So, kung solve natin ang x component ng D1, so that is D cosine theta. So, D1 cosine theta. So, remember, pag x, gagamitin ang cosine. Yan. Kaya naging D1x equals 55 nautical miles times cosine 63 degrees. So, that is 25 nautical miles. Ang kunin natin yung dy. So, dy is equal to d1 sine theta. So, siya ay 55 nautical miles times sine 63 degrees. So, we have 49 nautical miles. Okay? So, yan ang mga values ng d1x and then d1y. Okay, now let's go to d2. Okay, so this time, let's solve for the x and y components of d2. Okay, so to solve for the x component of d2, okay, so diba, pag x, gagamitin natin ng cosine. So this will be d2 times cosine theta. So that's 140 nautical miles times cosine 333. So sagot natin is 124.7 nautical miles. And then for d2y, so pag y, gagamitin natin ang sine. So we have 140 nautical miles times sine 333. So the answer is negative 63.6 nautical miles. So if you notice, negative yung sign ng d2y kasi di ba nasa south ito. Yan, ito yung y component niya. Kaya siya negative, and south is using the negative sign. Now next, ilalagay natin sa table yung nakuhang sagot. Ito ni-add natin ng x components at ang y components para makuha yung components ng total displacement. So magiging ganito yung itsura ng table natin. Yan. So, this is your vectors, d1, d2, and then dt. So, ito yung mga x components niya. So, sa d1, that's 25. Sa d2, that's 124.7. So, pag in-add natin to, we will get this answer, 149.7. So, yung y component naman natin, so we will add yung sa d1, that's 49, and then negative 63.6 sa d2. So, negative 14.6 sa dt. So, dito, nakuha na natin kung ano yung x component and y components ng total displacement. So, next naman, gagamit tayo ng Pythagorean theorem para ma-compute ang total displacement. So, kung gagawin natin yan, so we have dt is equal to the square root of dx squared plus dy squared. So, ito na yun. Ito na yung 149.7 squared plus negative 14.6 squared. So, pag in-add natin yan and then we will get the square root, we will get a total value of dt na 150.4 nautical miles. Okay, but remember, this one is only the pinaka-answer niya na hindi pa kasama yung direction. So, paano natin mako-compute yung direction? Okay, so since vector quantity ang displacement, so kailangan natin makuha ang angle. So dito gagamit na tayo ng tangent ratio para ma-solve to. Di ba kanina sabi natin, pag meron kang maghahanap ka ng angle, so gagamitin natin siya ng inverse tangent. So here we have inverse tangent of dy over dx. So pag sinubstitute, that's the inverse tangent of negative 14.6 nautical miles over 149.7 nautical miles. So, if you notice yung unit na nautical miles, makakancel to. So, pag ginamitan nyo ito ng calculator, ang lalabas sa sagot dyan ay negative 5.6 degrees. So, ang question is, paano natin ito draw yung negative 0.5 degrees? So, ganito yon. So, ang ibig sabihin ng negative angle sa calculator, yung angle ay susukatin natin from the positive x-axis in a clockwise direction. So, clockwise. So, from positive x going in a clockwise direction. So, ganito siya. Yan. So, positive x going in a clockwise direction. So, ito yung negative 5.6. So, ibig sabihin itong angle na to, ito yung 5.6. So, para makuha naman ng bearing, so remember, kailangan natin simulan magsukat ng angle from the north. So, sa case na to, i-add lang natin yung 90 degrees dun sa angle na nakuha natin. Okay, kaya, theta is equal to 90 degrees plus 5.6 degrees. So, this is the true bearing. 95.6 true north. Okay. Bakit ganon? Kasi remember, ito kanina yung 5.6 eh. Pero since galing ka sa north, ito is equal to 90 degrees. Okay? Kaya yun na yung magiging bearing niya. So this now will be your final answer. dt is equal to 150.4 nautical miles, 95.6 degrees true north. Okay, so this time let's have speed. So speed is a scalar quantity that describes how fast an object covers the distance. So it is defined as the total distance traveled per total time of travel. So in equation, so we have this. So the total distance divided by total time. Okay, so ang speed ay nagsasabi sa atin kung gaano kabilis gumalaw ang isang bagay. So dahil scalar quantity to, ibig sabihin, hindi na natin kailangan i-consider yung direction. So, for example, ang mga examples ng unit of speed, these ones are the very common ones. So, we have meters per second, kilometers per hour, or nautical miles per hour, which is also what we call as knot. So, yung nautical miles per hour is also equivalent to knot, which is madalas natin ginagamit pagdating sa mga navigation problems. Okay, so this time, let's discuss about velocity. So, velocity is a vector quantity that describes the change in position per unit time. It is defined as the total displacement per total time of travel. So, in equation, and we have this, velocity is equal to displacement over time. Okay, so, ang velocity ay nagsasabi sa atin kung gaano kabilis ang pagbabago sa posisyon ng isang object. So, dahil vector quantity ito, kailangan nating i-consider ang direction. Ang units nito ay parehas din ng units ng speed. So, meron din siyang kilometers per hour, or knots, or meters per second. So, ang speed ay mas mataas ang value kaysa sa velocity kapag ang object ay pabago-bago ng direksyon. At ang speed ay parehas ng value ng velocity kapag ang object ay hindi nagbabago ng direksyon. So, para tong sa distance at saka sa displacement. So, magkaparehas ng value yung distance at saka displacement kapag hindi nagbabago ang direksyon ng object. Pero kapag nagbabago ang direksyon ng object, usually mas mataas ang distance kaysa sa displacement. Ganun din sa speed at saka sa velocity. Kapag pabago-bago ang direksyon ng object, mas mataas ang value ng speed kaysa sa velocity. Pero kapag hindi magbabago ang direksyon ng object, parehas lang yung value nilang dalawa. Okay, so let's take this example. A ship travels 55 nautical miles on a bearing of 27 degrees and then travels a bearing of 170 degrees for 140 nautical miles. Find the distance and displacement of the ship. So if the entire motion lasted for 10 hours, calculate the average speed and the average velocity of the ship. Okay, so para ma-solve natin tong problem, so kailangan muna natin isulat lahat ng given and unknown quantities. Okay, so sa given natin, meron tayong D1 is 55 nautical miles, 27 degrees true north. Ito yun. And then D2 is 140 nautical miles, 170 degrees true north. And time of 10 hours. So, hanapin natin ang speed and yung velocity. Okay, so first, kailangan natin isolve ang total distance at ang total displacement. Pero dahil na-solve na natin ito sa previous problem, doon sa binigyan natin na example, so balikan na lang natin yung nakuha nating sagot. So, yung total distance na nakuha natin is 195 nautical miles. And yung total displacement na nakuha natin previously is 150.4 nautical miles, 95.6 degrees true north. Okay, next, isosolve muna natin ang speed. So, ang speed ng formula natin is total distance over time. So, yung total distance na 195 nautical miles, i-divide lang natin siya sa 10 hours. So, we have the value of 19.5 nautical miles per hour or 19.5 knots. So, ito yung ating average speed. Now, solve naman natin yung velocity. So, this time we have velocity is equal to total displacement over time. So, meron tayong 150.4 nautical miles divided by 10 hours. So, we have 15.04 knots. So, yung direction kanina ng displacement, kukopayin lang natin siya. So, that's 95.6 degrees true north. So, this time, let's have example number 2. So, in example number 2, calculate the speed of a ship that travels a distance of 866 nautical miles in 2 days and 90 minutes. So, what is the speed of the ship in knots? Okay, so to solve the problem, syempre, isusulat muna natin lahat ng unknown, lahat ng given at saka unknown quantities. Okay, so given natin, meron tayong distance na 866 nautical miles. Meron tayong time na 2 days and 90 minutes. And hahanapin natin ang speed. Okay, so ang nasa equivalent sa nautical miles per hour. So, kailangan muna natin i-convert ang time sa hour. So, ganito natin siya i-convert. So, kung mapapansin nyo, yung gagamitin natin yung factor na for 1 day, you have 24 hours. And then for 1 hour, you have 60 minutes. So, kapag nagawa na natin to, so magiging value ng time natin is ayan, 48 hours plus 1.5 hours is equal to 49.5 hours. So, kailangan natin siya i-convert sa hours kasi ang hinahanap na unit dito ay knots. Ang knots ay nautical miles per hour. Kaya kailangan ang time natin ay nasa unit ng hour. Okay, so next, i-compute na natin ang speed. So, yung speed natin is equal to distance over time. So, substitute lang natin. So, you have 866 nautical miles divided by 49.5 hours. So, we have a value of 17.5 knots. So, ito yung ating final answer. Okay, so let's have another example. So, example number 3, the speed of light is 3 times 10 to the 8 meters per second. How long does it take light to travel the 1.49 times 10 to the 11th meters distance from the sun to the earth? Okay, so para ma-solve natin yung problem, so kailangan muna nating kuhanin lahat ng given and unknown quantities. So sa given natin, we have given speed of 3 times 10 to the 8 meters per second. And then you have a distance of 1.49 times 10 to the 8 meters. Okay, so ang hinahanap natin dito is yung ito, how long does it take? So we're looking for the time. Okay, so gagamitin natin ang formula ng speed para ma-compute ang time. So we know that the speed is equal to distance over time. So para makuha natin yung value ng time, kailangan natin i-translate yung equation. So ang easiest way para gawin yun is pagpalitin lang natin yung pwesta ng speed at saka time. So magiging ganito siya. Time is equal to distance over speed. So pag sinubstitute natin siya, okay, so we will get a final answer of 496.7 seconds. So this is the total time it takes for the sunlight to reach the earth. Okay, so this time let's have acceleration. So acceleration is a vector quantity and it is defined as the rate at which an object changes its velocity. So meron tayong dalawang factors na nakaka-affect na acceleration. So ito yung the object's rate of motion and the direction of motion. So since diba sabi natin yung acceleration is a vector quantity, and remember that vector quantities have numbers and units and they also have direction. Kaya dito yung isa, itong rate of motion refers to the number And then, of course, you have the direction. Okay, so sa equation, we have the following. So the acceleration is equal to the change in velocity. So that's final velocity minus initial velocity divided by the time. Yung sa acceleration, nagsasabi sa atin kung gaano kabilis magbago ang velocity ng isang moving object. So dito, ang sinusukat natin is yung bilis ng pag-change ng velocity. So, ang unit ng acceleration ay meter per second squared. So, kapag positive ang acceleration, ang ibig sabihin nito, pabilis ng pabilis ang movement ng object. At kapag negative naman ang acceleration, ang ibig sabihin nito, pabagal ang object hanggang sa huminto na to. Minsan, ang tawag din natin dito ay deceleration. So, for example, meron kang given na acceleration na 2 meters per second square. Ibig sabihin nun, yung object, dadagdagan yung velocity niya ng 2 meters per second every second. So, kailan tayo nagkakaroon ng acceleration? So, merong different scenario. So, yung unang scenario, kapag nagbago ang velocity. So, ibig sabihin, pwedeng bumagal o bumilis siya. So, either mag-increase or mag-decrease ang object, ang velocity ng object. And then, yung second naman is, kapag nagbago ang direction ng object. So, for example, dati siyang papunta ng north, tapos bigla siya to turn sa east. Okay, so yun, meron kang change in direction, kaya meron ding acceleration doon. Kahit na hindi nababago yung velocity niya. Okay, for example, yung ship mo, meron siyang velocity na 25 knots going north. And then, bigla ka ng change in direction, naging 25 knots east. Okay, so may acceleration pa doon? Yes, meron. Kasi nagbago yung direction, kahit hindi nagbago yung velocity. Okay, so kapag ang object ay parehas ng bago ang velocity at direction. Okay, so this time, pag parehas na, pwede ka rin magkaroon ng acceleration doon. So, pwedeng kunwari, dati 17 knots ang velocity mo, and then ang direction mo, let's say, is north. And then, magto-turn ka, and then nag-turn ka, let's say, sa west. So, at magbago ka rin ng velocity. So, let's say from 17 knots, naging 15 knots na lang. So, 15 knots west. So, sa case na yun, parehas nagbago yung velocity mo at yung direction. Kaya, pwede nating sabihin na magkaroon ka doon ng acceleration. Okay, so let's have an example. In 1935, a French destroyer, La Terrible, started from rest and accelerated to attain a speed of 83 kilometers per hour. Suppose it took 2 minutes for the ship to speed up. Find the ship's average acceleration in meters per second squared. Okay, so para ma-solve natin yung problem, so kailangan muna natin isulat lahat ng given and unknown quantities. So meron tayong given na, okay, initial velocity is 0. Bakit? Kasi ang sabi din sa problem, it started from rest. So kapag yung object nag-start from rest, ang ibig sabihin nito, ang initial velocity ay 0. And then you have a final velocity of 83 kilometers per hour. Then time na 2 minutes. And we're looking for the acceleration. Okay, so dahil naka-meters per second ang unit na acceleration, now notice na yung time na given natin is minutes. Okay, so kailangan muna natin convert ang kilometers per hour at ang minutes nito into seconds. So, katulad nito. Yung kilometers per hour kasi, dapat ang maging unit nito is meters per second muna. Okay, para maging final unit natin ang meters per second squared. Okay, so mag-convert muna tayo. So, yung 83 kilometers per hour, i-convert natin sa meters per second. So, gagamitan natin siya ng conversion factor na for every 1 kilometer, you have 1,000 meters. And then, for 1 hour, you have 3,600 seconds. So, makakancel natin dito yung kilometers and yung hour. So, maiiwan na lang tayo ng unit na meter per second. So, the final answer for this is 23.1 meters per second. Okay, now yung time naman na 120 minutes. So, i-multiply natin siya sa conversion factor na 60 seconds over 1 minute. Kasi diba for 1 minute, you have 60 seconds. So, we have 120 seconds. So, cancel na yung minutes dito. Now, kapag na-convert natin lahat ng kailangan ng units, ang tawag dito, aligned na siya. Okay, aligned na. So, kung pwede na natin isa pang problem using the formula for acceleration. Okay, so yung acceleration formula natin is V2 minus V1 over T. So, pag sinubstitute natin, so 23.1 meters per second minus 0 over 120 seconds. So, we have a final answer of 0.19 meters per second squared. So, therefore, this is the acceleration of the destroyer. So, ano ibig sabihin ito? Pag i-quantify natin siya, ang ibig sabihin niya, yung ship, mag-change yung velocity niya, nadadagdagan yun ng 0.19 meters per second every second. Okay, so, mapapansin nyo, positive yung value nito kasi ibig sabihin nagdadagdagan yung velocity ng ship. Kapag ito negative, ang ibig sabihin nababawasan yung speed ng ship. Okay, so let's have another example. A ship with a mass of 5.22 times 10 to the 7 kilograms has engines capable of an acceleration equal to 0.357 meters per second squared. So, suppose a ship approaches the dock at a speed of 16.98 meters per second. How much time does the ship need to stop? Okay. So, gagawin muna natin, isulat muna natin lahat ng given. So, given natin, yung acceleration natin is 0.357 meters per second squared. So, ito yon. So, again, if you notice, hindi natin, mapapansin nyo naka-negative siya. So, ibig sabihin, pabagal na pabagal yung ship hanggang sa huminto na siya. And then, meron tayo ditong mass. Okay, if you notice, hindi natin siya sinama dito sa given kasi hindi naman natin siya kailangan dun sa problem. So, ang susulat lang natin dun sa given is yung mga given quantities na kailangan natin for the problem. So, in this case, meron tayong initial velocity or initial speed na 16.98 meters per second. Okay. So, mapapansin nyo, speed yung given dito, pero di ba yung acceleration is velocity over time? Yes, kaya lang, since dito, in-assume natin na hindi naman kasi nagbago yung direction ng ship. Kaya ibig sabihin, yung value ng velocity niya is parehas din ng value ng speed. And then, yung final velocity natin is 0. Bakit? Kasi sabi dito sa problem, ayan, mag-i-stop yung ship. Kaya ang final velocity nun ay 0. So, this time, mga hanapin naman natin is the time. Sabi dito, how much time? Okay, so note, importante yung reading comprehension sa physics kasi may mga quantities na nakadepende sa kung anong nakasulat sa word problem. So, katulad kanina, di ba? Yung from rest, ibig sabihin, initial velocity is 0. Dito naman, kapag sinabi na the object will stop, okay, ibig sabihin, ang final velocity naman niya ay equal to 0. Okay, so, based sa given, so magsasubstitute na tayo using the formula ng acceleration which is final velocity minus initial velocity over time. So, pag sinubstitute natin, pag translate tayo ng equation, so ang mahanap kasi natin is yung time. So, the easiest way to do that is pagpaligtarin lang natin yung pwesto ng time at saka ng acceleration. So, therefore, to find out what the time is, so you have V2 minus V1 over A. So, pag sinubstitute natin, meron tayong 0 minus 16.98 meters per second divided by negative 0.357 meters per second square. So, if you notice, yung ating, di ba dito parehas na negative siya. So, makakancel yung negative sign, kaya magiging dito positive na. So, that would be 47.6 seconds. So, ibig sabihin, it takes the ship 47.6 seconds for it to stop, given na meron kang ganitong value ng acceleration. Okay, now sa mga problems natin, meron tayong tinatawag na uniformly accelerated motion or UAM. Pag sinabi natin uniformly accelerated motion, ibig sabihin, constant yung ating acceleration. Kailan to applicable? Kaya ginagamit natin to kapag may mga movement ng object along the horizontal line or along the x-axis. For example, yung movement ng car habang nasa kalsada siya. So, along the horizontal axis yun. Pwede rin siyang applicable sa vertical motion. So, free fall. Ibig sabihin kapag yung object nalalaglag siya. Okay? So, for example, meron kang ball from, let's say, from the second floor and then kusa siyang nalaglag papunta sa first floor. So, yun is sinasabi natin na freely falling yung ball. So, you can also apply UAM there. And then finally, pwede rin natin siyang gamitin sa two-dimensional motion na ang tawag natin is projectile motion. Projectile motion is, for example, naghagis ka ng baseball. So, yung baseball, habang nagmumove siya horizontally along the x-axis, meron din siyang vertical movement. Okay, habang kasi bumabagsak siya, ang movement niya horizontal. Okay, so yung combination na yun, kung papansin nyo, ang path niya is parang parabola, or parang curve line. So, yun yung tinatawag natin na projectile motion ng isang object. Okay, so again, I emphasize na kapag sinabi natin uniformly accelerated motion, ibig sabihin constant ang acceleration. Ibig sabihin, hindi nagbabago yung value ng acceleration natin. Okay? Huwag niyo isipin na zero yung acceleration ha, kasi pag sinabi natin zero acceleration, ibig sabihin nun constant yung velocity or hindi nagbabago ang velocity. Pero pag sinabi natin constant acceleration, ibig sabihin yung velocity mo pabilis ng pabilis, pero fix lang yung rate niya. Okay, so these are the examples. These are the 4 equations na ginagamit natin sa uniformly accelerated motion. So, nilagay natin dito sa chart na yung may check, ito yung mga variables na makikita nyo sa equation. Tapos yung may x, ito yung variables na wala dito sa equation na to. Yan. So, bakit ito importante? Kasi gagamitin natin to as a guide kapag nag-solve tayo ng problems later on. Kasi pag nag-solve ka ng problem for uniformly accelerated motion, very important na ang pipiliin mong equation ay yung makikita mo lahat ng variables sa iisang equation. Depende dun sa given na problem. Okay, let's have an example. So, a hovercraft, also known as an air-cushioned vehicle, glides on a cushion of air, allowing it to travel with equal ease on land or water. Suppose a hovercraft undergoes constant uniform acceleration, which causes the hovercraft to move from rest to a speed of 30.8 meters per second. How long does the hovercraft accelerate if it travels a distance of 493 meters? Okay, so again, para ma-solve natin siya, kailangan muna natin i-identify yung ating mga given and unknown quantities. Okay, so ang given natin, okay, initial velocity natin is 0. Okay, bakit sinabing 0? Again, kasi sabi dito, the hovercraft to move from rest. Okay, nag-start siya from rest. Kaya initial velocity is 0. So, next velocity niya, final velocity is 30.8 meters per second. So, sabi dito, to a speed of 30.8 meters per second. Again, bakit speed? Kasi yung velocity at saka yung speed niya rito parehas lang dahil hindi naman nag-change ng direction ang hovercraft. Okay, so, meron tayong given dito na distance na 493 meters. So, ang question is the time. So, how long does the hovercraft accelerate? Okay, so, hahanapin natin dito ang time. Okay, so ngayon, sinabi sa problem na constant uniform acceleration. So, since sinabi sa problem na constant uniform acceleration, ibig sabihin, pwede tayong gumamit ng UAM equations. So, pipili lang tayo ng variable na meron lahat ng values na nakasulat sa given. Okay, so ito na yung mga equations natin kanina, no? So, ang given natin is V sub 1, V sub 2, D, at saka T. Okay, so hahanapin natin ngayon dito. Nasaan dito sa mga equations na to yun? Okay, so i-compare natin ang given sa equation. So, dapat lahat ng nasa given ay makikita natin sa equation natin. Okay, so tingnan natin sa V1. Okay, so sa V1, ano nang meron dyan na V1? Okay, so, meron tayong V1 dito, meron din dito, meron din dito, meron din dito. Okay. Next, hanapin natin yung sa VF. Okay. So, dito, merong V1 at saka VF. Pero dito, walang VF. Okay. So, ibig sabihin, hindi na natin ito pwedeng isama sa pwede natin i-consider. Dito, merong VF. Okay, check. So, pwede natin itong isama sa pagpipilian. And then, ito namang isa, meron kang V1 saka VF. Okay, good. So, big sabihin, ito, hindi na to kasama si consider natin yung second equation. So, ito na lang tatlo yung pagpipilian. Okay, next variable. Hanapin natin kung saan merong D. Okay. So, dito sa first equation, wala siyang D. Okay, so, hindi natin to pwedeng gamitin. Okay. So, na lang natitira, ito na lang dalawa. Okay. So, dito merong D at saka dito meron din. Okay. So, ibig sabihin, yung ating hinahanap is nakalimit na lang tayo sa pagpipilian dito sa dalawang equation na to. Okay. And then, this time, kailangan nating hanapin kung nasaan dyan yung merong D. Okay. So, nasaan yun? So, between the two, nandito yun yung makikita yung merong variable na D. Yan. So, mapapansin nyo dito sa ating table, okay, lahat ng may check na to, okay, it points out to this equation. Okay. So, therefore, ito yung gagamitin natin na UAM equation. D is equal to VI plus VF over 2 times D. Okay, so now ready na tayo mag-substitute. So, very careful kayo sa substitution. Okay? So, this time, ang hinahanap kasi natin is T. Okay? So, para ma-solve si T, ano kailangan natin gawin? Ita-transform natin yung ating equation. So, para magawa yun, i-divide natin both sides of the equation by this one. Para maiwan dito yung T. So, ganito magiging itsura niya. Ayan. So, pag dinivide natin to lahat by V1 plus VF over 2, okay, ganito na magiging itsura niya. Kasi dito, makakancel na siya. So, now if you will substitute, so you have D is 493 meters divided by, okay, ito muna isusolve nyo. 0 plus 30.8 divided by 2. So, pag gagawin nyo ito sa calculator, make sure na yung calculator nyo mayroong ganito, open close parenthesis. Okay? Kasi kapag wala nito, hindi kayo gagamit ito, mag-iiba yung final answer nyo dito. Or another option na pwede nyo gawin is, ito muna ang isolve nyo. Kung ano yung makuha nyong sagot dito, yun ang ipang-divide nyo dun sa 493. So, therefore, the final answer here is 32 seconds. And so, it takes the hovercraft to accelerate within 32 seconds. Okay, next example. So, a ship moving with a constant acceleration of 36 kilometers per hour squared in a fixed direction speeds up from 12 kilometers per hour to 18 kilometers per hour. So, find the distance traversed by the ship in this period. Okay, so again, hanapin muna natin yung mga given quantities at yung unknown. So, yung acceleration natin is 36 kilometers per hour squared. And then, yung initial velocity natin is 12 kilometers per hour. And the final velocity is 18 kilometers per hour. Again, sabi dito, fixed direction, kaya yung speed natin is the same as the velocity. So, pinapahanap sa atin yung distance. Okay, distance traversed by the ship in this period. So, kailangan pa ba nating mag-convert ng units? Hindi na. Hindi natin kailangan mag-convert ng units kasi wala naman tayong, lahat naman sila is consistent with each other. Okay, so consistent yung 36 kilometers, sa 12 kilometers, at saka sa 18 kilometers. At saka wala din namang sinabi dun sa problem na yung unit mo is kailangang maging meter for the distance. So, proceed as it is. Okay, so sinabi din sa problem ng constant acceleration. So, dahil constant acceleration to, ibig sabihin, pwede tayong gumamit ng UAM equations. Okay, so ito na yung mga given natin. Okay, so based sa given na to, so hanapin natin kung nasan yung mga same values, same variables within the problem. Okay, so first, let's look for, okay, so V1. So, ang V1 natin, dito natin makikita, ayan, so lahat na equations meron V1. Next, VF. So, again, tatanggalin na natin to, hindi na to kasama kasi ito na lang pagpipilian mo. So, VF squared. Okay, tsaka ito, meron ding VF. And then yung D, okay, so nasa nito ang may D. So, dito sa tatlo, ang D, dito nyo makikita sa dalawa na lang. So, dalawa na lang itong pagpipilian. And then finally, we will look for A. Kasi given yung acceleration dito. So, sa dalawang to, ang merong A lang ay itong pangatlo. Okay, so ibig sabihin, ito yung equation na gagamitin natin. So, again, tinan nyo, lahat ito may check. So, it falls under this equation. Okay, so this time, we will need to transform the equation para ma-solve natin ang distance. Okay, so yung equation na napili natin is Vf squared equals Vi squared plus 2AD. So, pag nag-transpose tayo, okay, so itong VI squared lilipat sa kabila. Kaya naging ganito, naging negative. And then, so, matitira na lang dito yung 2AD. So, para ma-solve yung D, i-divide natin both sides by 2A. Ayan. Kaya naging ganito yung final equation natin. So, pag sinubstitute natin to, nagiging sagot natin is a total distance of 6.5 kilometers. So, that means, during the time of the acceleration, ito yung distance na na-cover niya, 6.5 kilometers.